Today, we're digging into a quality check that's absolutely fundamental to the safety of our roads, our bridges, basically all of our most critical infrastructure. We're talking about the concrete cube test.
I mean, really think about that for a second. When you're driving over a huge flyover, how do we know for sure that the concrete holding everything up can handle that unbelievable day-in, day-out pressure? It's a huge question of public safety and, honestly, trust.
Well, the answer, and this might surprise you, doesn't start with the massive structure itself. Nope, it all begins with a small, pretty unassuming cube of concrete. This is the story of that little cube and how it gives us the proof we absolutely need.
So here's what we're going to walk through. First, why this test is so important. Then, how these little test cubes are made. It's a whole process. We'll look at the crush test itself, how to make sense of the results, and finally, how it all comes together to guarantee the quality of our roads.
All right, so let's start with the big why. Why go to all this trouble for a simple block of concrete? Well, it's about building a literal foundation of trust. At its heart, the concrete cube test is a standardized method. Its whole purpose is to measure compressive strength, which is really just a fancy way of saying how much of a squeeze can this concrete take before it breaks. This isn't just a suggestion, it's a critical quality check to make sure the concrete being poured is exactly as strong as the engineers designed it to be.
And why does it matter so much? Well, the stakes couldn't be higher. This is all about guaranteeing public safety. It ensures our roads and bridges are built to last for decades. And, very importantly, it's how we verify that the construction follows the strict standards set by bodies like the Indian Roads Congress and the Ministry of Road Transport and Highways, or MORTH. You can think of it as the final report card that says, yes, this concrete makes the grade.
Okay, so how is it actually done? The entire test is only as good as the sample you start with, so creating the perfect specimen is everything. You just can't afford to mess this part up.
And it all starts with this one specific number. The standard test cube, according to the Indian specifications, has to be a perfect cube, 150 by 150 by 150 millimeters. This exact size is crucial because it makes sure that all test results from any project anywhere in the country are consistent and can be compared, apples to apples.
Now, you can't just take one sample and call it a day. The MORTH rules are very specific about how often these cubes have to be made. For something like a dry lean concrete base, you're taking 3 samples for every 1,000 square meters. For the actual pavement you drive on, it's a whole set of samples for every 150 cubic meters of concrete. This frequency is what ensures the quality is consistent through the entire project.
Making the cube is this really precise 3-step dance. First, you fill the mold with fresh concrete, but you do it in 3 perfectly equal layers. After each layer, you have to compact it with a special vibrating hammer to get all the tiny air bubbles out. And finally, you smooth the top surface so it's perfectly flat. Every single step is designed to create a solid, uniform sample that's a perfect representation of the concrete in the actual structure.
Once the cube is made, it's not ready to go. Not yet. It has to be prepared for its big moment, the moment of truth we call the crush test.
And this next part, curing, is so important. See, curing is the process where concrete actually develops its strength. The cubes are usually kept submerged in water or in a special room with controlled humidity, all following the Indian standard IS 1516. If you skip this or do it wrong, the test results are basically useless. The cubes get tested at 2 key points. There's a test at 7 days, which is kind of like an early progress report. It gives engineers a good hint if the concrete is on the right track. But the main event, the final exam, is the 28-day test. By then, the concrete is expected to be at its full design strength, and this is the result that really counts.
So for the test itself, they take the cured cube and place it inside this incredibly powerful machine. It then applies a crushing force, slowly but continuously, from the top and bottom. The machine precisely measures the force being applied right up until that dramatic moment when the cube finally fractures and fails. That maximum force it could take, that's its compressive strength.
So, the cube has been crushed. We have the numbers. Now what? This is where we have to decode those numbers to see if the concrete officially passes or fails. Before we look at the pass-fail rules, you need to know this one term, characteristic strength, or FCK. Now, this isn't the average strength. It's actually a statistical value. Think of it this way. It's the strength that 95% of the test samples are expected to be stronger than. It's a built-in safety margin that accounts for the fact that not every single bit of concrete will be identical.
And MORTH lays out the acceptance criteria in black and white. There's no gray area.
For dry lean concrete, the average of 5 cubes tested at 7 days has to be at least 10 megapascals, and not a single cube can be below 7.5. For the really important stuff, pavement and structural concrete, the average has to meet or beat that characteristic strength, FCK, and no individual sample can be too far below it. These are the hard and fast rules.
Now for the question that every single site engineer dreads. What happens if the cubes fail the test? Does it mean you have to rip everything out and start over? Well, not necessarily.
If the initial cube tests don't pass, there's a backup plan, core testing. They use a special drill to pull a cylindrical sample, a core, directly out of the hardened structure on the road. These cores then go to the lab to get crushed, just like the cubes. The rules are a little different for these. The average strength has to be at least 85% of what was designed, but this gives a final, definitive answer on the actual strength of the concrete that's already in place. And that brings us to the end game, connecting this very technical test back to the real-world quality of the infrastructure we all depend on.
It's pretty amazing when you stop and think about it. All of the design, all of the money, all of the work that goes into building a massive highway or a bridge. It all hinges on the proven strength of its most basic ingredient. And that confidence, that proof, comes from this small, standardized 150-millimeter cube of concrete.
This quote, straight from the MORTH specifications, says it all perfectly. This isn't just a good idea or a best practice, it shall be analyzed. That's not a suggestion, it's a command. Checking these results for conformity is the final gatekeeper for quality and safety. It's non-negotiable. So, that leaves us with a final question to think about. Compressive strength is, without a doubt, a pillar of construction, but it's just one piece of a much larger puzzle. As we look to build the even more resilient infrastructure of tomorrow, what other qualities, things like flexibility, how it handles water, or even its surface texture, will become just as essential for us to test and verify? That's the challenge ahead.